Hi, welcome back to Chem with Chem. In this session, we will be working question 5 of Chemistry Paper 2 from the January 2020 sitting. If this is your first time to the channel, welcome. Please check out the other videos that are here. Leave a like if you find value, share, consider subscribing and turning on post notifications so you'll be alerted the moment new material is added. Let's dive right in. This question is on organic chemistry, reactions of esters, reactions of organic compounds to be more specific, and we're just going to kick it off. Compound C, part A. Compound C is a sweet smelling compound which is often used in flavoring and perfumes. All right, so once we hear anything relating to sweet smelling compound in organic chemistry, then we should be thinking about ester and ester. Once we hear sweet smelling compound, we should be thinking about an ester. All right, so they want us to actually name compound C and to give the homologous series to which it belongs. So we know it belongs to an ester, sweet smelling compounds. Esters tend to be fragrant, at least the shorter chain ones. All right, so in naming an ester, this is how we do it. First we identify, we'll verify that it's an ester by looking for the ester linkage, and we see the ester linkage here. So it's C double bond O O. Now normally put a little squiggle line. Those are sticky ends, which are actually bonds that are attached to other parts of the molecule. So that's the ester bond. So we start off knowing it's an ester by saying bond, ester, bond. So we have an ester linkage. All right, so two things make up an ester. An ester is formed from an alcohol and an organic acid. So the alcohol part is at the end. The alcohol portion is at the end. So this part is coming from our alcohol, and the part at the front is coming from our acid. Now, when we're naming the ester, we name the alcohol part first. So even though the alcohol part is at the end, we name the alcohol part first, and we name the acid part last. So let's check out what we have here. For the alcohol, we have a CH3 group. So this alcohol, this part of the ester was formed from an alcohol that is 1 carbon long. So that is definitely coming from methanol. So this is coming from methanol. So we will name this part methyl. So we're not saying this is methanol, we're saying it's coming from methanol. So this is really the methyl group. And since we name the alcohol part first, we will say that this is methyl, that's the CH3 group. And then the other part coming from the acid now, this part, the first part or the front part, it's made up of 3 carbons, 1, 2, 3. So that would have been formed from propanoic acid. So the name of the compound would be methyl propanoate. Methyl from the alcohol part, propanoate coming from the acid part, which is propanoic acid. So this compound is methyl propanoate. Methyl propanoate. And the homologous series, as we said earlier, is an ester, or is ester. All right, and that would have given us 2 marks. Let's complete this for the O. Draw the fully displayed structural formulae of the 2 molecules that are produced when compound C is hydrolyzed. All right, so let us clear our screen so we can get a good understanding of what's happening here. We want things to be as clear as possible. So hydrolysis, whenever we say hydrolysis, we know it has to do with the splitting of water. So to be able to do the backward reaction or to break up this compound, we have to understand what happened when it was formed. When the compound was formed to begin with, we would have had the OH. We would have had the OH from our acid joining with the H from our alcohol. And that part would have been pinched off, for want of a better word, to give us our water. So in the backward reaction or the reverse reaction, which is what we're doing now, we're going to be Let's clear up the molecule. We're going to look in the ester bond, and so we're going to do a little background check, and it's just for us to appreciate how we got the compound in the first place. Because if we know how we got the compound in the first place, then it's easier to actually break it apart. All right, so we're going to draw propanoic acid. We're going to draw propanoic acid. So propanoic acid is CH3CH2 COOH. Let's put on the hydrogens. So that's propanoic acid. And we're going to draw methanol beside it, and we're going to draw methanol in blue. So we're going to put the OH part of methanol at the front, and we'll have the other part of the molecule, CH3OH. So this is our propanoic acid and our methanol. So propanoic acid is in red. So let's just, so this is propanoic acid, and this is our methanol. So these are the formula of the two compounds. So we can just do that right away. So we'll do that, and that's the answer. But I just want us to look at how we get the joining, how we get them forming the ester bond. So under the right conditions of heat, acid catalyst, and under reflux, we would have, let's use a different color, we would have the OH from the COOH functional group of the acid. We'll have that part actually going with the H, joining with the H from the alcohol. When that happens, water will be eliminated. So this is what we'll actually have. And we're just keeping the color consistent so we can see where everything is coming from. So this is still H2O, we're just writing in a different way. So we can see that part of the H, one of the H's, the H actually came from the methanol, and the OH came from the acid. So what would happen now? The water would be eliminated as that small molecule, and then let us look at where the joining will occur. So this part here is going to be joined to this part here. So let us just reproduce that. So we'll have an arrow to say what we get. So this would be, let's start from the left, would have CH3, CH2, then we'd have C double bond O, and then we're at the part that we just took off the OH. So we'd have a bond right there, and then we'd have the alcohol part now, O, then CH3. And let us just highlight the bond, the ester bond that was formed. So this is the ester bond that we just formed right here. And the ester bond was formed here. It's formed right here. So this is the part that we join in yellow. Let's make it a little more conspicuous. So let's use green then. So that's the ester bond that was formed. So to actually get the products that are, to actually get the compounds that would have given this compound, the formula of the compounds that would have given this ester, we would actually go in and we look in the ester bond, and we always cut. We would cut right here, right after the C double bond. Oh, let me draw a squiggly, a black line to represent that. So we cut the bond right there. When we cut the bond, we're going to have, we can now take the water molecule, split the water molecule, split it back into OH and H. And we're pretty much putting on back the OH where it came from the acid. And we're putting on back the H from the alcohol. So what would really end up with is CH3, CH2, CO, that's C double bond O, then OH. That's the acid, and would also have CH3 OH. So that's the fully displayed structural formulae of the two molecules that are produced when C is hydrolyzed. Part B, ethanol is widely used as a solvent for making cosmetics and perfumes. State the name of compound D and identify the reagents and conditions necessary for ethanol to be converted into compound D. So this is ethanol. Well, it's labeled ethanol is here, and on the right-hand side, we have compound D, which is ethanoic acid. Ethanoic acid. So the name of compound D, ethanoic acid, and we get a mark for that. And they want us to identify the reagents and conditions necessary for ethanol to be converted into compound D. So we would need acidified, we'll need a very powerful oxidizing agent. So we would need acidified potassium manganate 7 or acidified potassium dichromate 6. So we could write out the words or we could write the formula. Acidified potassium manganate 7, in bracket we could put H plus slash KMNO4 or acidified potassium dichromate 6. Out of space here, so this would be H plus slash K2CR2O7. All right, and 3 more marks on our tally. Explain how ethanol can be made from the fermentation of sugar. Include the chemical equation for the overall fermentation process. All right, so very important. We'll start out by just stating the sugar or sugar solution in aqueous medium is reacted with yeast, which contains the enzyme zymase. The conditions for the reaction, 37 degrees Celsius is the optimum temperature. It shouldn't be brought above that. And we need the correct pH. We don't have to state the pH. So the glucose would pretty much be converted into ethanol and carbon dioxide. At 12%, the yeast will be killed, and so the reaction would stop. And so then we would have to distill the mixture by a fractional distillation in order to get a higher concentration of ethanol. So that is pretty much it in a nutshell. So we're just going to write that down. All right, so the other thing that must be noted, right, we need to state the correct pH because the enzyme zymase, they are pH sensitive. So if the pH is too low, it can render the enzyme inactive. And also we must state that the optimum temperature, the temperature used is 37 degrees Celsius. I hope this is clear. So let's just fix that. All right, and they said in part 3 now, for the last mark to give us the full marks, to give us the full 15, state one other use of ethanol. So we cannot state any of the uses that were already given. So they stated that it's used as solvents in the manufacturing of perfumes. So we'd have to use another use. We'd have to give another use. So another use we could give is that ethanol is used as fuel. We know about E10. So ethanol is added to gasoline. And I mean, ethanol by itself, it is used in spirit lamps. It burns with a clean blue flame. And just like that, we would have gotten 15 marks. So thank you again for joining Chem with Chem. And be sure to check out the other videos. Look for the card that is popping up. Look for the other questions related to this paper. If you don't see them now, just check back in a few days. They should be there. If you haven't subscribed, consider subscribing and turning on post notification so you won't miss anytime new material is added. Copper later.